Capacitive sensors work by measuring the amount of electric current that flows between the probe's sensing surface and ground, which is usually connected to the target. The current flows through the capacitance between the probe and the target. The closer the probe is to the target, the greater the capacitance and the greater the current flow. For sensing current to flow, it must find a path to ground. Anything that resists the current flow to ground can interfere in the measurement. Therefore, the effect of using an ungrounded target depends on the alternate path the sensing current takes to ground and the amount of resistance it encounters along that path. Often, ungrounded targets, such as spindle rotors, have a significant amount of their surface area very near a grounded surface. The capacitance between such targets and ground is much higher than the capacitance between the probe and the target. If the capacitance between the target and ground is at least 100 times higher than the capacitance between the probe and the target, the current flows easily through the capacitance and no errors are created. Errors caused by ungrounded targets may include offset errors, which relate to the measurement of absolute distance to the target, and sensitivity errors, which relate to measurement of changes in the target position. Offset errors are usually of no consequence because capacitive measurements are typically taken relative to some point rather than absolute gap measurements. Sensitivity errors can be more problematic because changes in the target position may be inaccurately measured. Electrical noise may also increase with ungrounded targets. The symptoms of an ungrounded target can include excessive electrical noise in the sensor output, unstable and drifty sensor output, or a sensor output that shifts when objects, such as hands, are brought near the target. When an ungrounded target is inevitable, there are techniques that eliminate or reduce the associated errors. The first and best solution uses a two-channel sensor system in which the two drive channels are synchronized but 180 degrees out of phase. In this configuration, the current path is out of one probe and into the other. Grounding is no longer an issue because the current path is provided by the second channel. The output of the second channel does not need to be used in the measurement. The second channel only provides a return path for the sensing current. Some measurements, such as two-channel thickness, can make use of both channels while eliminating ungrounded errors. It is important to keep in mind that using two channels has no benefit unless they are synchronized and 180 degrees out of phase. For this reason, Lion Precision's Elite series and compact drivers provide 180-degree phase differences between even and odd channels on every system. Another solution to grounding issues is to use a grounded piece of flexible conductor as a brush to maintain a ground connection to an otherwise ungrounded target. Strips of copper or a metal brush will work well for this. Simply connect the strip or brush to ground and hold the piece against the target while measuring. Lion Precision Elite Series sensors provide ground connections on the front panels of the drivers to facilitate this technique. Ungrounded targets present potential error sources for capacitive sensing systems. The techniques presented here can reduce or even completely eliminate these errors. If you have any questions, please contact us right away.